Hello and welcome to Beginner's Python and Machine Learning. My name is Tim Cummings. Tonight we're going to be looking at how to create Excel spreadsheets using Python. And we're going to be using a third-party library, xlsxwriter. Now the point of these sessions is for you to learn how to do things. There's plenty of tutorials on the web, but this is different in that you can ask questions. So we'll be watching the chat on YouTube, and I'll also be watching the chat in our Slack channel. If you look down below in the comments in YouTube or on our meetup, it tells you how to get an invitation to our Slack channel. Learning to Code is the channel within Slack that we'll be using. We're going to be using Google Colab tonight, so you don't need to have Python installed on your computer. You can do the exercises if you're using Python on your computer, but for now it's probably easier. Alright, I'll talk up a bit. I'll just check my volume levels. Testing. Alright, I'll just move them up. Yep, they're at a maximum. Okay, so we're going to use Google Colab, so all you need is a Google account and the internet access, which obviously you do have access to the internet. So I've got a link here to our Jupyter notebook. This is our meetup page, but the link is also on the YouTube page. And if you click on that link, it will open up a new tab or a new window that has a Jupyter notebook, which is a way of writing Python using interactive Python, and it's very powerful and it's really good for learning. So please ask questions in Slack and on the YouTube chat. Otherwise, I'll just keep powering on. Once you've got your Google Colab opened, you'll see a link here, copy to drive, and that clicking on that will give you your own copy. So I'm going to click on that because I'm in a different account now. And when I've got my own copy, then I'll be able to make changes and save those changes. Now, if you want to see the changes that I'm making, I'm going to share the link to this one as well. So if you don't want to do any typing, you can just use this link and just load it, reload the page, and you'll get all the changing that I've done. So I want anyone with this link, we'll copy that link and I'll paste it into our Slack channel, and I'll paste it on YouTube chat. Right, now Google Colab is a Jupyter notebook, so it's made up of these cells. You can see there's a border around each cell. The cells can be either text or code, and we can add in new text cells or new code cells. This one at the top is a text cell, so it's just describing what's going to happen, and this one here is a code cell, and this one's a code cell as well. Now, to create Excel spreadsheets, one of the things we want to do is have some data to put into our Excel spreadsheets. So what I'm going to do is I'm going to grab all the Python scripts that we've written during our online meetups, and I'm going to make a summary table of those into an Excel spreadsheet. Now this is very similar to the xlsx virtual printer that we created in Meetup 110. But in that one we've used quite a lot of technology. We didn't have time to go through it, so now we're going to go through the Excel technology that we use there. Alright, so the very first thing, we're going to connect. If you click on connect up here, that'll connect to Google Colab, so I'll do that and that'll save a bit of time later. Otherwise, the first time you type something into one of these cells, it will be a little bit slow. Now the first command we're going to do is we're going to clone our GitHub repository where all our scripts are kept. This is a public repository, so you can get a copy of that, and we just use the git clone command. Now this is a command line command, not a Python command. So in Google Colab, when you're running command line operations, you use the exclamation mark. So we've put an exclamation mark out the front, and then we type in our command line, and then we can press play. And that's now copied all the files into our local work area. Now with Google Colab work areas, the files will stay there until you quit, and then you'll lose the files. So make sure that if you want to save any of your files, that you do save them somewhere more permanent. Here they all is our session summaries online, so you can see all the scripts that we've been putting up to GitHub. There's also, you can mount your own Google Drive here. I'm not going to bother doing that, but if you mount that, then you'll be able to, you can save files straight to your Google Drive. So if you want to play around with the command line here, you can try a few things. So for example, to find out what operating system we're running, it's I can just type in new name, the Unix name, and so we're running Linux, and it just gives us our kernel version there. So that's what Google has given us as a little Linux box. We can have so we can just use Linux commands here. We can find out what shell we've got. So we're running the bash shell. So bash is, we can just use commands like ls. ls, oh, there you go, ls worked without the exclamation mark. And there it is with the exclamation mark. Alright, let's do some Python now. We've got our folder that we want, which is called Session Summaries Online. So we'll put that into a path variable, and then we can do things with that. So our online directory is just called is just Session Summaries Online, and then we're going to get a list of all the scripts that are in there that end in .py. So in those scripts we have the .py ones are the Python scripts, and we've got some IPYNBs, which are the notebooks. So I tend not to store notebooks in GitHub because they're not very legible in GitHub. If you're making changes to them, it's hard to spot the changes, although GitHub will format them to show you. So I just like to use the Python scripts, and if you want to use the notebooks, then you can just use the links that we provide. And I'll just look at the ones that I've created rather than the ones that Arun's created as well. So let's have a look at that. We'll run this cell, and we get the names of all the scripts that we've done since we've gone online. They're all out of order. And right at the end I said, tell me what the type of each of those scripts in list scripts is, and it's a pathlib POSIX path. So POSIX is a name for Unix, which isn't trademarked, and so Python has classes there for Windows paths and classes for POSIX paths, because they do behave slightly differently. But normally you just use the superclass, which is path, and you just use the functions that work the same way in both cases. Alright, so let's sort our list, and we can do that with a list, which is just a standard Python list, by using the .sort method. So let's sort it and have a look, and we can see now that they're all in order, 52, 53, 54, all the way up to 119. Right, so if you don't understand something that I'm doing, make sure you ask questions. I'm happy to go over anything. It's supposed to be for beginners. Okay, so we're going to use the xlsxwriter library. It's a third-party library, so it doesn't come with Python. And in fact, I don't think it even comes with Anaconda. It doesn't come with Google Colab, so we have to install it. So this is, once again, we do that from the command line. We use !pip install xlsxwriter. Now, if you're doing this on your own computer with your own Python install, I'd like to create a virtual environment, and then and often I'll then create a file called requirements.txt, and then I'll pip install all the contents of requirements.txt. But Google Colab's giving us our own virtual environment, so we can just install straight into that and not affect anyone else and not affect any of our other projects. Okay, so there's some good documentation for how to use xlsxwriter at .readthedocs.io. So, but I'll just go through a few of the things that we can do. What you would normally do is you create a workbook by running this workbook class with the name of the workbook in it, and then we can do things like add worksheets and stuff like that. Now, I've put all this in a with command, so you see the with here, and then indented everything underneath it. And the advantage of using with, I recommend using with whenever you can. Use it whenever you're opening files, and here where you do it, we're opening a file. It's a new file we're creating, and what it does is when you leave that code block that's in the with, then it will automatically close the file and free up any resources that have happened, that have been allocated by what we've done here, which is opening the file. And I can never remember to do things like close files, so if I put it into a with, I know that that's going to be handled for me automatically. Alright, so we create our workbook, and we'll just call it in a variable called workbook, and then into that workbook we'll add a worksheet called scripts, and we'll store that worksheet into our variable called worksheet. And so worksheets are just the tabs. Each tab in an Excel spreadsheet is called a worksheet, and the whole collection of worksheets is called a workbook, which is the file. Alright, and then we're going to go through all the scripts in list scripts, and we're just going to write down what the file name is. Now we're going to convert it to a string because this command here wouldn't know what to do with a path, so POSIX path. So we convert that to a string, just using the standard way in Python to convert to a string, which is using string as a function name. It's going to go into this row and this column, and these are 0 index, so that's a little bit of a trap for rookies. So I is going to go from 0, and we're going to put everything in the first column. So A1 is actually 0, 0. Alright, so let's run this little script. It's only, we've got to import this library that we've created, so it's only after importing, it's 1, 2, 3, 4 lines of code. Okay, so that's run. It was pretty quick, and what you'll see eventually when this refreshes, actually we'll try a refresh, there we go, we can see this new spreadsheet that we've created. So I can download that spreadsheet down to my computer, and then I can open it. So you can open it in Excel. I don't have Excel on this computer, but I've got LibreOffice. So let's have a look at what we got. Alright, so that's our spreadsheet. You see there's a tab here called scripts. There's no other tabs. The name we called it, which is Beginners Python Machine Learning Links -0. We'll make that column a bit wider so that we don't have those vertical lines. and that worked pretty easily. So what more is there to do? Okay, so Leo says, Leo's asked a question: what Python versions support with is it greater than 2.7? Yes, I'm not sure. I'd think so. I don't recommend writing any Python 2 code these days, so just write Python 3. But maybe later we can look that up and see what when with was introduced to Python. So I just made some column changes, so it's asking me to save, but I won't save. Alright, so let's have a look at what our pathlib can do. And it's so purepath is a superclass of POSIX path, and we want to just get the file name. We don't want to have all the directories in front of it. So how do we do that? So let's just look at the first one and look at these different ways. So S is the script as a path, and then we just use some of these properties that I looked up on the library, the pathlib documentation on the Python site. And so name gives us the name without the beginning directories. Stem gives us that same name without the suffix at the end. We can even find out what the suffix is by looking at and it tells us it's .py. We can see the parent is the directories, and you can even look at parents, which is a list of parents there. So this is parent, this is parent.parent. So online is our parent, session summaries is our parent.parent, and then dot, which is the current directory that Google Colab is in, is the great-grandparent. So task 1, store index I in column A and the script name without the suffix in column B. Alright, so let's just copy some code so we don't have to type so much. So I recommend you can pause the video at this point and have a go at doing this exercise yourself, and then play the video to see how we've done it. Either that or you can just watch along. Alright, so let's get rid of some of these comments. So we want the index in column 0. I forgot to talk about this enumerate. That's a nice little function in Python. When you are going through a list of scripts, a list of anything, sometimes you'll do it by its index. So you'll say for I in range length of list scripts, or sometimes you'll do it by the values. So you'll say for script in list scripts. But sometimes you want both the index and the name. So enumerate will give you both of those as a tuple, so then you can have two values here in your for statement, each one getting a different part of it. So one's getting the index and one's getting the value. So then we can use those indexes here for our row numbers, and we can use the values in our column B. Alright, and this is task 1. So let's run this script and see what we've created. That was pretty quick. Let's refresh. Yep, there's our Excel spreadsheet. Let's have a look to see if it worked. And sure enough, we've got numbers in column A, and we've got strings in column B. We've got the full string. We were supposed to do that without the path to it. So we'll just say script dot, and let's use stem. Okay, refresh that, and that will be the new one. So we'll download the new one. And yes, now we've got rid of the directory path, and we've got rid of the suffix. So now we've just got the file names on their own, and we've got our index. So you can see here, index 0 went into row 1, index 1 goes into row 2, because Excel uses 1-based row numbers and xlsxwriter uses 0-based. Alright, so let's have a look at the solution. The solution's a little bit different. So the solution has well, let's run the solution so we can see what's created, and then we'll go through it. So that ran it, and now let's download it. Okay, we'll close that. Right, so we've got we've put some heading names in here, and so we moved everything else down a row, and then everything else looks the same. So they've got their code down here is the same, except they've put I+1 for the row number to make room for this heading. Now when we've put the headings in here, we've used the A1 type references, so they can work as well. So I've got a question here. Is file name changes automatically with new suffix? Okay, so our file name is here. This is the file name that we're saving, and so when we close out of the with code block, it'll close the file. In that case, it actually saves it all to the file system. So in the file system, it'll have exactly that name. So if the name existed before, it will overwrite the name, that file, with the new file. Now you'll notice down when I'm downloading it that each one is getting an extra number on the end, but that's just what Google Chrome is using. What Google Chrome does when you download a file that's got the same name as something already in your downloads folder, it just puts an extra suffix on there so that they can both exist in the downloads folder at the same time. Alright, so here we've got the rather than using two parameters being row and column, we're using the cell references the way that Excel normally does it, which is A1, B1, and often that is a lot easier to understand. So I'd recommend that if you can. But when you're going over lots of rows, then sometimes this format is an easier one to use. Just remember that it's 0 indexed. The other thing we've done in the solution here is set the column width of column B. So the second column, so B column B, so you can set several columns at once. We want it to be a width of 50, and that's made it wide enough to fit all those script names in there. Everything else is the same. Alright, task 2. Use the A1 type references to write script stems. Alright, let's have a go at that. So it's going to be a little tricky. How are we going to convert our numbers into strings? So this I+1 0, we want to convert that into A and then I+1. So we want to do a little bit of string manipulation there. So the first time we go through that, I is going to be 0. So I+1 is going to be 1, and that's going to put it on Excel row number 2. So let's create a new variable called row equals I plus 2, and then we'll put it in here. And I think we could probably use format strings as an easy way of doing this. So column A, and then we can just have the row number. So that will be the first time through, that'll be 2, and A2, it'll put in the value I. And to write the script stems, I didn't need to do it there, but we can leave it there. F B row. All right, so can you see how that's creating these string type references out of the integer values that we had? We'll put that into Excel version 2, and we'll run that. Yes, I forgot to delete this parameter. Oh, the other thing I didn't point out in our solution 1 was we used just write the first time, and we could put write as a number or write as a string, and really write is just an alias for all these other sorts of things that you can write. So sometimes you might find that it's putting it in the wrong format, in which case you can explicitly say, I want this one to be a number and this one to be a string, which is what we've done here. Okay, and let's test our solution to task 2. There it is. I'll download that and have a look at what we got. And it should work the same way. And we've got our column width as well. So let's look at the solution 2. So there's a few new things that have been introduced here in the solution. So let's just run it and see what we can see what it looks like, and then we'll look back at the Python code to see how that was achieved. Is everyone having success in creating these Excel files? Just let me know if they're not working. All right, so here we've centered this column, so that looks a bit neater than before. And we've got a formula here in the in cell 41. It's currently value 0, but if I press the F9 key, it'll calculate that to 3,207. So we've managed to put in a formula equals sum A2 to A39. If you open that in Excel, you would have seen that the formula automatically calculated when the file was opened. LibreOffice deliberately doesn't do that because they say then you can lose some information that was there when the file was saved, because it now might recalculate with a new value, and people can use the F9 key or Control-Shift F9 to recalculate anything that if they want to then get the recalculated values. If you really like the way Excel works in LibreOffice, there is a setting that you can set so that it will actually recalculate as you open the file. So let's see how we put the formula in, and let's see how we put in those, we set that formatting. You can see the formatting there, it's center aligned. So we created a format here, and we added it to the workbook. So add format, so it can be used on any worksheet within the workbook. And then anytime we wanted to use it, we just put it as an additional parameter in our write function. So we, in our heading for the meetup, we said we want that to be formatted in the center, and when we wrote the index, it's doing something else. So the other thing it's doing is it's looking at the script name and getting the meetup number, not just the row number. So that's a bit more useful to us. And when it's displaying that format center. Now there's a whole bunch of formats that you can apply, and that's why a dictionary is a reasonably good way of putting them in. You can just add lots and lots of formats together in one long thing. But so look up the documentation to see all the different formats that you can have there. And here's how we did a formula. So we just used write, and we pasted in a string. So the string, we knew it had to start at A2, and it went A up to the last row that we put in here. And that was the formula. And because xlsxwriter saw that it was a string that started with equals, it's put it in as a formula for us. So we didn't need to do write formula. But you might find that sometimes you want to put in a string that starts with equals, but you want it to be staying as a string, and that's an example of a time where you'd want to put write string here. And we use center formatting. All right, format the first row in bold using bold true. Okay, so we're formatting the first column as aligned center and the first row in bold. So let's have a go at that. I just love copying and pasting. So we'll create a new format called format bold, and we'll add it to the workbook. And it's just a dictionary. Okay, and we can do that on the first row. So we'll do format bold for all these on the first row. And then all the other rows will format center in the first column and no formatting on the second column. Okay, so I think that's everything it asked for us in task 3. Oh, we better call it number 3. So there's our spreadsheet. Let's have a look at that. So the first row is bold. We've got centered here, and you'll see here's our meetup numbers: 52 for meetup 052, 53 for meetup 053. One small problem is that's centered, but that's left aligned. So it doesn't look 100%. And there's our total. Any questions on how we created that spreadsheet? All right, let's have a look at the solution. There's a lot more stuff going on here, showing some examples of different formats. So let's run it and see. Shift enter. And we'll download our new task 3 spreadsheet, and you see it's put the Google Chrome's put the brackets 1 on it. So we've put in 0 padded meetup numbers here, and that was achieved. Let's close this. So this number format here gave us 0 padded meetup numbers. We've got bold equals true in the first row, and the other thing we've managed to do is we've got centering and bold in the first cell there in A1. So how do we do that? Now you'd think it would be pretty easy to just merge a couple of dictionaries together, or I mean we could have easily created a brand new dictionary from scratch, but we thought, well, we want everything in column A to have all those formats and everything in row 1 to have these formats. So how do we create the formats that are going to be in cell A1? So we want to merge two dictionaries together, but we don't want to affect the originals, because we can still use those originals for other places. Now, so what I've done here, and this is the way you would have to do this in anything prior to Python 3.5, is I've created an empty dictionary for cell A1, and then I've updated that with all the formats for column A, and then I've updated it with all the formats for row 1. And so it gets a merge of all of those parameters, and it if there were any parameters in row 1 that were the same keys as column A, then the row 1 ones would win. It would overwrite the column A ones. But fortunately we don't have any of those, but we do get a merged dictionary. Now if you are using Python 3.5 to 3.8, I mean it still keeps working after 3.8, you could have created dictionary A1 in one line using that code. But Python 3.9 has actually got some new, even newer code of a way of doing that, and that's using this vertical pipe for a union of those two dictionaries. So I hope you understand why we couldn't just say DCF col A update DCF row 1, because that would have changed the contents of DCF col A. Now once we've got our dictionary sorted out, we can create our workbooks. So we just added a format for column A using the dictionary for column A, format for row 1 using a dictionary for row 1, and the format for A1 just using the dictionary for A1. So think for yourself how you would merge two dictionaries if you didn't know about this. I've given you a solution here, but even if you didn't know about the update command, you could have done it with a for loop. You could have done a for loop through everything in DCF row 1 and assigned those keys and values into DCF A1, and done the same for DCF col A. Alright, anything else new? Everything else there looks the same. Yeah, so it's really just the formatting that we've achieved here. Alright, now we're going to try to extract some data out of these files. So let's do a little bit of an exercise in how to read data out of files and collate it in Python, and then we can put that into our spreadsheet. So let's play with some things here. So to open a file, we use the open command, and that takes a file name, and it's by default it's read mode as a text file, and with no encoding. All right, I'd actually normally probably if you're going to be running this cross-platform, it's best to specify an encoding, because the Python uses the default file encoding for each platform, but these days everything's going to be in UTF-8. So in here I'm going to say encoding equals UTF-8, because we're reading Python scripts, so they should all be encoded in UTF-8. So Python scripts are all in UTF-8, but a standard text file is assumed to be in the platform's default encoding. Alright, so once the file's open, we store that into a variable f. We use the with command, so f gets closed automatically when we're finished with it. And then we have to read the lines in it. So we can use f.readLines, will give us a list of all the lines. We can even just we can iterate over f, and that will return line at a time. But both those solutions will actually keep the new line at the end of each line on it, and we'd prefer not to have that. So we'll just read it all in as one string, and then we'll use the string function split lines to split it, and that gets rid of those new lines off the end. And then we're just going to look at the first 10 lines here from line 0 to 9 using a slice of that list, and we're going to print it. So let's see what the first 10 lines look like in our script. There we go. So they're the first 10 lines. We've got a couple of lines here defining what to do with it. So we've got a shebang line that tells us that it's written for Python 3. We've got another encoding line to tell us what encoding is being used. And then we've got a doc string. So the doc string starts with triple double quotes and starts to explain what's in this script, and that goes on for quite a while. Alright, so the question is, how would you connect to different data source like SQL or Dynamics 365? So you're going to use a third-party library if you want to connect to those sort of data sources. Python comes with Sqlite built in, so if you want to write your own SQL code, then just using Sqlite is a really easy way to install it. But we've actually got other sessions that explain how to use MySQL and MongoDB. I haven't done anything with Dynamics 365, so I can't help you there. Alright. So task 4. Open the 20-second file and read the first 10 lines. So that's going to be pretty similar to this. So the first file has index 0, so the 20-second file is going to have index 21. And look at the first 10 lines. So there we go, meetup 087. You can see it's slightly different. It doesn't have the shebang line in it because this was a code that's designed to run inside of LibreOffice. The doc string has got an R out the front because there are a lot of backslashes in the doc string, so we decided to call it a raw string, and that made it easier. We didn't have to escape all the characters in our doc string. In fact, these days I always put an R out there in front of the doc strings. Alright, and you can see that it's got different information. So one's got YouTube, Colab and Github information, and this one's got YouTube source and sample. Okay, Leo said here, the data law add-on that comes with PyCharm Pro has drivers and viewers for most databases. Okay, so I'm presuming that's for if you're just wanting to inspect the databases from within PyCharm Pro. I'm not sure. You would still need to install the drivers for database connections in the code that you're running within PyCharm Pro, because you then want it to be able to be installed somewhere else where PyCharm Pro doesn't exist, and so in that case you would need to make sure that the drivers go with it. Okay, let's look at solution 4. So remember, we're reading through a file here, and we read the whole thing as a string, then split the lines in the solution here we tried the read lines, and you'll notice we've put the strip in there. So I'm going to take out the strip so to show you what happens if you don't have it there. And then when we print each one of those lines, it prints the line and the new line, and then at the end of the print statement it prints another new line. So we get double spacing there. So we want to get rid of the new line that's actually in the string itself, and just let the print command do the new lines. Okay, so that worked. It gave us the same file. Okay, so we want to find the title line in the file. So the title line is this line here that is the first line of the doc string. So I'll make this a bit wider so we can read it. So the title line, it can start with triple double quotes, or it can start with triple single quotes. Sometimes we can have an R out the front to say it's a raw string. We could even have an F out the front and saying it's a format string. Or we could have an R and an F, or an F and an R. So there's lots of different combinations. So if we're going to try to check for each of those different ways of writing this first string, there'll be a lot of code and logic that we'd have to put in. So I thought I'd just do a quick introduction to regular expressions. And what a regular expression does is it is a way of creating a string like this that has all the formats built into it, and the logic. So this is saying we're looking for a line that starts, so the circumflex means the beginning of the line starts with, and then we're going to have either F or R, or either an F or an R, and we can have zero up between 0 and 2 of them. So it can be an F, it can be an R, it can be an RF, it can be an FR, or it can be neither. After that, we want to have an apostrophe or a double quote, and we've had to escape the double quote using the backslash there. So that's a regular expression escape, not a Python string escape, because we've used raw strings out here. We don't need to do Python string escaping. And we're going to have 3 of them, followed by, so we're not accepting singles, which is probably correct, because the doc string should really have a triple quotes there. And then we have as many characters as we like after that to the end of the line. Alright, now if you struggle with these regular expressions, I recommend going to a website like regex101.com, and you just tell it that you're using Python and you want to use this regular expression, and it'll explain what it does. And the other thing you can do is you can put in the code that you want it to look for, and it'll tell you whether it matches or not. So there's the string that we're looking for, and we say here, so we're matching a single character present in the list below. So it's an F or an R, and it's got to match it between 0 and 2 times, as many times as possible. And then we're going to look in the list below, we're going to look for either a single quote or a double quote, and have exactly 3 of them. So these are lots of fun. I recommend don't spend too much time on them, because you'll just go crazy. But every now and then have a go at them, and you'll gradually build up your skills in regular expressions. Pro version of PyCharm is not free. In fact, I've only used the community edition myself. Alright, so we've got a regular expression. We compile it up and put it into our regular expression pattern here, and then we use pattern to match the line. So we didn't actually need to put the circumflex there, because match actually finds anything that's right at the beginning of the string. And so what we're going to do here is we're going to read the script, and then we're going to iterate over every line within that script. Then we're going to see if it matches our regular expression. If it does, we're going to append it to a list, and then we're going to jump out of this loop, which is this for line here. So we're only going to get one line per file, and then we'll move on to the next file. And then we're going to have all of them in our list of strings here called list meetup, and we'll print them out. So let's try running that and see how well our regular expressions went. It seems to have worked pretty well. We've gone through each one of those files, and we've taken out the first line of the doc string in each one of those. Now you can see some of the times I've used raw strings and other times I haven't. We've put dates in there. Sometimes I've put in the day as a name, a number, a month, and a year. Sometimes I've left out the day, but I've put in the number as with some code on the end, 31st or 24th, and other times I've just gone 07. So it's a bit of a mishmash there. So how are we going to, we want to work out the date that each one of these meetups occurred. So we're going to use the string parse time, but you can see with string parse time, we have to put in a format exactly how it appears. So if the date is like that, we could use %d, %b, %Y. But if there's a th there, we have to put th into our parsing format string. And you'll see that they both work. And if I didn't have the th there, you can see that that doesn't work. So we need the th in there. So that's going to be a bit awkward how to do that. So can we use regular expressions to solve that? And I've just written up a function here, date from meetup, that uses this regular expression. So we're looking for 1 or 2 digits, followed by optionally followed by 2 characters. So it's either 0 or 2, but not 1, followed by a space, and then followed, they're letters actually, then followed by exactly 3 letters, and then followed by exactly 4 digits. And I use these m.group to get the first, third, and fourth, because I'm not really interested in that group there. And I can then reconstruct a string that will be in the correct format for parsing using parse time. So let's check if that code works. I'm just skimming over this because it's regular expressions and they can be a minefield. And you can see we've got all the dates coming out correctly. Alright, so task 5, use regular expression to find the YouTube URL for each meetup. Alright, so we've done it before for the format string here for docstring. So let's grab these. Let's see, our pattern for YouTube is really just got anything that's got YouTube in the title. So we just maybe a colon. That should do. But it could be, I can't remember whether I've put upper or lowercase y and upper or lowercase t. So what we'll do is we'll convert the line to lowercase. Now the YouTube doesn't necessarily have to be at the beginning. It could be indented, so we can't use match, but we can use search, and we'll stick that into a list of strings called list YouTube. And once we found the YouTube link, we'll just break out. And so some of them might actually miss out on having a YouTube link. No, they've all got YouTube links. All right, so let's see how that went. Yep, that's a function, not a property. Search. There we go. There's all our YouTube links, and you see one of them I put a dash in the front just to confuse things. All right, let's have a look at the solution. So the solution is defined a function, so we can use it later for other things, and it's looking for YouTube, but it's also looking for anything else that we give it. So it's searching in the line for, it's converting to lowercase. That's good. Our pattern title, it's got the pattern there from before, but we're going to create a bunch of pattern titles for every different title that's come in. So we could have YouTube, we could have Colab, we could have Meetup, and it's going to have the name converted to lowercase, followed by a colon, and then we actually don't want the name and the colon. All we're trying to return is everything after that, so we'll put that in parentheses, and then that'll go into our group 1, and we'll do that for all our case. So let's try that function with just passing in YouTube, and it gives us both the doc string and our YouTube URL in the dictionary, so it's matched them one to the other. So we're getting some data now that's really useful, and we could be putting this into our Excel spreadsheet. Similarly, we can run that same function but with all 4 different types, or 4 of the different types. We've actually got more than that, and this is just for the first one. And you can see we've got YouTube, we've got Colab, we've got Github, and there was no Meetup in the first one. All right, create a spreadsheet with columns, and we have Meetup and script in sheet scripts, and then in the second we're going to have Meetup, date, YouTube, Meetup. So that's the Meetup number, that's the Meetup URL, Colab and Github, and the doc string. All right, well, let's copy some code to create this spreadsheet. I'll go back. So here's some code that creates the first worksheet in our spreadsheet. And I might make this a bit shorter. We can delete all of this. DCFA1, let's use the, we're in Python 3.7 here on Google Colab, so we can use this format here. That'll save a few lines. And I can just type that straight into there, so that gets rid of all of that. We've got the format. Don't really need a total anymore. Okay, so that creates our first worksheet, and then we'll create a new worksheet for our second bit of information. and we'll call this one links. And create a spreadsheet with columns, and this is going to be in sheet links. So we want meetup, date, YouTube. Okay, for I, comma, script in I better create some headings. So these are really good exercise to do yourself as well. It's fairly laborious creating these the first time, but once it's done, then it can save you, people can really get a lot of value out of these spreadsheets that you can create. And so you can put some nice formatting in there, and then every one that gets developed, produced automatically has all that nice formatting in it already. All right, now we want to, for every script, let's grab this code as well. And then we can use, we want to use this stuff. So how is it? Oh, it's just a dictionary. Yep, let's grab one of those. So I'll store that into a dictionary. The scripts, we've already got a value here that's going to go through each one, and that'll put those into the dictionary for us. So we can add in, we want to put a date first. So let's use I+1 for row number, column number 1, and dictionary. We're going to use our function that we created before for date, which can get it from the meetup, and the function was called. So you can see how a function that we define up here can be used later on. So it's date from meetup, and we have to give it the meetup, the first line of the doc string. Date from meetup. and then we want YouTube. Meetup, Colab, Github, docstring in each column. Okay, we'll see how that goes. I've got the colon at the end. Key error meetup. Yes. So we're looking at a dictionary for these keys, but the keys might not exist because they don't exist in every one of them. So rather than using square brackets, we're going to use the dictionary get function that will get it if it exists, and if not, just returns a none. And I put that into 3, should have gone to 6. Anyway, we'll just look at it in 3. So here's our spreadsheet. You can see it's got 2 tabs, script and links. And in links, we've got our meetup. We've got the dates. We didn't format the dates, so they're just looking like the raw data, which is the number of days since 1900. Then we've got our YouTube URLs. We've got our meetup URLs, our Colab URLs, and our Github URLs, and then our doc strings. So that's effectively what the task was asking for, and now we've got a nice little database here showing all the links to all the different YouTube videos that we've created in this online phase of beginners Python and machine learning. So let's have a look at the solution. Solution's thrown in a few extra things. So we've created this function URL last, which is going to find the last segment of the URL. Because one of the problems was our URLs are so long that they're overflowing the columns, and it's hard to see much on there at once. And we don't really need to see HTTPS YouTube on each line, but we do want to be able to click on the URL to take us to that YouTube. So we've got a method in there to do that. We've put formatting in. That's all pretty standard. We've set some column widths in our links worksheet, so that'll make it look a bit better. We've created a date format. That's what we've done here, num format, so dd space mmm space yyyy. So we can use that for our dates. We've put in another one here, source, because sometimes it's GitHub, sometimes it's source. And we're going to put them both in the same column, I think. So there's a bit of extra logic that's down here required to do that. We've looped through these titles so that we didn't have to rewrite so much code. We've used the write URL rather than write, and that gives us the advantage that we can specify the string we want displayed as well as the URL that we want to be able to click on. So let's try running this and see what it looks like. So our first page looks the same, and the second page you can see it's a lot neater. We've managed to shorten down these URLs. I can hover over them and it's got the full URL there, https://YouTube. The meetup, it's got the full hyperlink there, so I can click on those to go to that address. And we see here that GitHub, the GitHub address, often I just put in online to show what folder it is in, but didn't actually say the file name. But then sometimes I put the file name in there as well, so we can see the file names are there when they're mentioned. Okay. Oh, and the description here, we've trimmed down the docstring title to just have the last part, which is the name describing what the session is all about. Okay, so we've got a question here. How to debug Python code? Is there step-by-step debugging? So in Google Colab, there's not really step-by-step because, but you can put one line per cell